In this example, we want to synthesize this di-substituted benzene starting with benzene, and it looks like it's probably going to be fairly simple to synthesize a di-substituted benzene, but we have this stipulation that it be free of any other isomers, which that adds a degree of difficulty. Also, we'll see that adding these two substituents meta to one another proves a little more difficult than you might think, so it's going to involve a little bit of strategy. So let's just think about what we might need to do here. Well, to get the methyl group on the aromatic ring, we're going to want to do a Friedel-Crafts alkylation. Okay, and to get the fluorine on the ring, we're going to have to do this through actually forming the diazonium ion at this position, and then we can treat this with HBF4 to convert that to the fluoride. Now, if we think about this, well, fluorine would be an orthopara director, so that's not going to help us out with the Friedel-Crafts, and additionally, this deactivating group probably wouldn't work well anyways, and the methyl group is an orthopara director. So how do we get a group installed meta to the methyl? So you might think, well, I could put a nitro group here, because nitros do direct meta. The problem is nitro is too deactive to do, or too deactivating on the ring to do the Friedel-Crafts reaction. So we can't do that. Again, our methyl group is an orthopara director, so that doesn't really help us out. So let's think about a strategy that we might be able to use to get these groups where we want them. So maybe we could start out by somehow installing a bulky activating group at this position on the ring. If it's an activating group, it directs orthopara, and if it's bulky, it's sort of going to block out these ortho positions. So if we have that, we can now install the methyl. So that lets us get our methyl group in position. Now what we can do is sort of remove the bulkiness of this group. So just get that back down to just a standard activating group. So now if we have an activating group here, we can install something at this ortho position that can then eventually be converted into the fluorine. So that will likely be a nitro group. Because we know we can convert the nitro into the diazonium ion. Now we have the two substituents at the positions we want them, but we have this activating group down here that we want to get rid of. Well, we can convert that activating group, if it's something like an NH2, just to a hydrogen. And we can do that via one of those diazonium ion reactions. So that'll get rid of that, and now all that's left to do is convert that NO2 to the fluorine. And we can do that by the diazonium ion reaction. So there's our basic strategy. So now let's use our basic strategy that we've developed to synthesize this compound. So we're going to start with benzene. Okay, and we wanted to put the bulky activating group down here at the bottom. So the first thing we need to do, we'll go ahead and nitrate. So we use nitric acid and sulfuric acid. That gives us a nitro group. We can now just reduce that to the amine. So use hydrogen and palladium on carbon. So here we can generate aniline. Now remember, we want a bulky activating group. NH2 is an activating group, a strong activating group, but it's not bulky. So we'll use acetic anhydride to acylate that. So now we have this bulky amide group that blocks out those ortho positions. From here, we can do the Friedel-Crafts reaction. So we'll use CH3Cl and AlCl3 as the catalyst. Now, although this AlCl3 isn't compatible with an NH2 group, because that lone pair will react with it in a Lewis acid-base reaction, this lone pair on the amide isn't nearly as Lewis basic, so you don't have to worry about that in this case. So we still have our bulky group. Now we've installed the methyl group at that para position. From here, now we can hydrolyze off that bulky group because we don't need it anymore. Just acid and water. And now that we have this activating group, which is an ortho-para director, we can install a nitro group ortho to it, which will make the nitro group meta to the methyl. It's just nitric acid, sulfuric acid. From here, now we can remove this NH2 group that we don't want anymore. So in order to do that, we'll treat that to NaNO2 and HCl to convert it to the diazonium ion. Now that we have this diazonium ion, we can treat that with H3PO2 to convert that to the hydrogen. So it essentially just removes it. Now we need to work on getting this nitro converted to the fluoride. So now we reduce the nitro to the NH2, convert that to the diazonium ion, NaNO2, an acid, and then finally HBF4 is reagent that you want to use to convert that to the fluoride. And now we're finished. So it was actually quite a lengthy synthesis to get to this fairly simple compound.